So I've got the Electron microscope up and running in the new garage, and this guy uses quite a bit of power, upwards of about 5,000 watts. So I just want to show off how I'm getting that power supply in the garage here. But first off, just to show you the devices that are using that power. For starters, there's quite a few pumps. There's 1, 2, 3 rotary pumps, and each of those are 120 volt devices, and I think it's about 700 to 800 watts for each motor. Next up is these 2 diffusion pumps. Each of those has a 500 watt heater on them. And all 3 these rotary pumps and those 2 diffusion pumps are operating at a constant duty cycle. The cooling water for those pumps is supplied by this water chiller. In this chiller plus the water pump and the control circuit takes another 300 to 400 watts. But by far the most power hungry device is this air compressor. Fortunately, this thing doesn't always have to run. It's maybe only on 10% of the time. But when it is running, it's a 12 amp, 120 volt motor. So that's another 1400 watts. So that kind of is the bulk of the power. The rest is only, I'm guessing, a total of 500 to 1,000 watts between the control console and the column console. So yeah, all in all, I'd say between 5,000 and 6,000 watts when everything's running, including the air compressor. So how am I getting that? I'm fortunate enough to have a 250 volt 30 amp circuit here in the garage. It's meant for the dryer, but this is a natural gas dryer, so actually this receptacle is totally free for me to use. Unfortunately though, this is an older house, so it uses this 3-prong dryer adapter. So that's 2 hot and 1 neutral. No earth ground, because I guess this is before appliances had to be safe. But it's pretty common for 4-prong dryers to be available these days. So this adapter is $20 on Amazon, and what it is a 4-prong to 3-prong adapter plus a ground. So to be safe, they give you this extra wire that you're supposed to run over to your standard I think that's a NEMA 515 receptacle. So you take the ground, plug it in there. The only thing that's a little bit fishy is that, that's a 15 amp circuit, but that receptacle is 30 amps, so you could have a 30 amp surge to ground, and I don't know if the wiring is rated for that 30 amps. So what I ran instead is my own ground to a ground clamp on the cold water pipe, the water heater here. And I've got 8 gauge wire, so that should be good for 30 amps. But I have a feeling that this is not 8 gauge. I think it actually is going to be 10 gauge, so I'm not totally safe, but I'm doing the best I can. So yeah, again, we got 3-prong to 4-prong splitter, and then that cable just goes to a twist lock. This is a NEMA L1430, which is again a 250 volt 30 amp circuit. These are more common for industrial equipment, but also backup generators. They're pretty commonly used on them. So then the next cable here is a kind of a Y splitter. It's an L1430 male to 2 L1430 females. And this is actually a pretty expensive cable. I guess it's not very common to want to do this, split a 250 volt 30 amp twist lock into 2 receptacles. But I kind of just went with this because this is the original connector from the Electron microscope. So yeah, this would normally be supplying the full power for the system, but all my rotary pumps are connected externally, not through the column console. So that's why I have this splitter. So this is probably a couple amps, and this is the bulk of the load. So the next cable here is another Y splitter, but in this case it's a L1430 male to your standard, I think this is a NEMA 520, your regular 20 amp circuit here in North America. And this is actually a pretty common and cheap cable, because for those people that are using backup generators, they want to take the twist lock and convert it into something that's normal to use. And then from here we just have the extension cords going out to everything that's back here, which is the air compressor, the water chiller, and the 3 rotary pumps. And technically this isn't really that safe because everything downstream of this is going to be rated for only 20 amps. But if you follow up, this is going to go back to the panel, which is a 30 amp circuit. So you could actually get 30 amps onto this cable if your load was, not acting properly. So this isn't really that safe, but I mean, I'm only going to be operating this when I'm in the room. And I guess that's why I also have the fire extinguisher ready and available to use. So yeah, I'm actually pretty happy with how this has turned out. I've had it running for well over an hour and haven't tripped any breakers yet. So far, so good.